Hello Geometry, and welcome to Chapter 4, which is going to be all about transformations. In this first section, we're going to be looking at translations, which is a type of transformation. And to begin with, we are going to introduce the concept of vectors. So, what is a vector? A vector, it sort of looks like a ray. In some ways, it is a ray. Remember, rays have an endpoint, which we are going to call the initial side. And then they have the arrow, which shows it keeps going, and that would be called, in this case, the terminal side, where the vector ends. What makes a vector? So a vector has what is called magnitude, which is a fancy word for length. All right, this just means length. But it also has direction. And you'll learn about vectors even more if you take physics. So a vector has magnitude and direction. And to represent a vector, so for instance, over here we have this vector PQ. So it starts, the initial side is at P. The terminal side here is at Q. And to get from P to Q, you had to go 5 units right and 3 units up. So the vector that goes from point P to point Q, notice that we put the endpoint over P because that's our initial side, is going to equal, now we use pointy brackets to represent a vector as opposed to parentheses, which is a coordinate. And so we put for the x, we're actually putting the distance you go in the x and the distance you go in the y. And that represents the vector PQ. So again, we're going to use the pointy brackets when we're talking about vectors. That would be called the vector form. All right? Okay. So, example 1, name the vector and write it in its component form. So this is a vector whose initial side is at B, terminal side is at K. So this would be the vector that goes from B to K. Now we want to figure out in the X direction, notice I'm going back because I'm going to the left, back 5, and I'm going up 2. So I would write this in vector form as -5, 2, and that's how I'm going to leave it. All right, find the slope of the line segment KB, and what do you notice? Well, the slope of BK, or KB, doesn't really matter, remember represents rise over run. So the rise in this case is I went up 2, the run was back 5. So notice that the slope is really the y component of the vector over the x component. And especially if you graph them, it's pretty easy to figure out what your slope is going to be from that. All right, so that's vectors. Now, we talked about we're doing transformations, right? What is a transformation? So a transformation is a function that moves or changes a shape. So if it moves it without actually changing the shape, we're going to call that a rigid transformation. If it changes the shape, it depends on how that shape changes. One way is if it makes it bigger or smaller. That we will address when we do dilations. All right, so when you are doing a transformation, you have an image and you have a pre-image. So the pre-image is what we start with. So you start with a pre-image, and then you use a rule or a set of rule, basically then you use some sort of a rule, might be more than one, to result in the image. So the image is going to be what is new. And in general, we tend to use the prime, I'm trying to see what we have here, as our image. And so we would have, oops, I just lost my place. So over here, notice that we have the triangle PQR. That would be, I'm trying to see, So PQR in this case, this would be the pre-image. And what we're doing is we're taking each Y value is going down by the same amount. Each X value is going over by the same amount. And it results in our image. So to represent them, notice now each point gets a prime put on it. So we have P prime, Q prime, R prime. So a translation. A translation basically is a rigid transformation. Translation, it moves every point in the shape, and I should say in the pre-image, the same distance and direction. The same distance and direction, which is kind of like a vector. Dun, da, da. Okay. So notice this went down 3 and over 4, or if we wanted to write that as a rule, that would be, let me see, I went forward 4 and I went down 3. That would be the vector that I moved, or the rule that used my pre-image to get to my image. So the rigid motion is what preserves the length and the angle measure of the pre-image when you transform it into a new image. So rigid, basically, or isometry, these both mean the same thing. It preserves the angle measures, so it doesn't stretch or change your shape. It preserves angle measures. It preserves length of a side from a pre-image to the image in a transformation. So basically, it just moves you to a new position. All right, so let's do this example here. We have the vertices of triangle ABC are A, which is at 0, 3, so that's going to be here, and B, which is at 2, 4, so here's B, and C, which is at 1, 0. All right, and so that is going to be our pre-image, ABC, and we are going to translate it using the vector -3, 2. So we had A, B, C. A was at the point 0, 3, B was at the point 2, 4, C was at the point 1, 0. So my new points, my image, A prime, B prime, C prime, without even, and again now let's write this rule in component form, what we're really doing. So notice here it's written in vector form. What you're doing is you're taking whatever your X value is and you're subtracting 3. Then you're going to take your Y value and you're going to add 2. That would be component form. So what is my new pre-image? So 0 minus 3 is a -3. 3 plus 2 is 5. For B, you have 2 minus 3 is a -1. 4 plus 2 is going to be at 6. C, 1 minus 3 is a -2, and 0 plus 2 is 2. So I'm using this rule to get my new coordinates. And notice you can also do it without, I just realized that this is a little bit off center. Let's make that a better line segment. All right, so now let's graph this just to see that it is truly the same shape. So -3, 5, we label that as A prime. -1, 6, that is going to be B prime. And -2, 2, that is going to be C prime. When we connect those, you can see it does look the same shape. It's just a matter of it's gone back 3 units and up 2 units for each point. All right, example 3, write a rule for the translation of ABC, the pre-image, to the image, A prime, B prime, C prime. So it's really important that you keep track of the direction. So again, this is my pre-image. And then this is going to be the final result. So in trying to figure out the rule, what do I do to get from one point to another? Here's A prime. 1, 2, 3, 4. Notice I went back 4, and I went up 1. And again, we could write that in component form like this. I myself tend to prefer the vector form. It's just a little bit shorter and easier to write, and that would be that rule. All right, here we go again. We have A for our pre-image is at -1, 5. We're going to want to graph these. B's at, oops, sorry about that, -1, 5 was my B value. A was at -1, 2. C is going to be at 4, 6, and D is going to be at 4, 2. So let's first put our pre-image on the graph. So at -1, 2, here's A. Always label your points. -1, 5, that's going to be my B. C is going to be at 4, 6. There's C, and at 4, 2 is going to be D. And now that I see where everything's going to be, I'm going to move my A to the outside here. All right, so I can kind of draw my quadrilateral. It's actually a trapezoid, but that's okay. And now they want us to transform this by the rule. And again, this would be in vector form 3, -1. So that means I'm going to go up 3 and down 1. Sorry, I said that wrong. I'm going to go forward in the x direction 3, down 1. So that means A prime is going to be -1 plus 3, which is at 2, 2 minus 1. And then B prime, we're going to just do the rule to each of these. So that's going to put me at 2, 4. C prime is going to be at 7, 5. And D prime is going to be at 7, 1. So we can see if we go to 2, 1, here's my A prime. 2, 4, it's going to be B prime. 7, 5, that's going to be C prime, and 7, 1, D prime. So you can notice that it should be the same size, the same shape, all the angles are the same. It's merely gotten translated 3 units forward, down 1 unit. Okay? Now, you can do more than one transformation, which would be called a composition of transformations. So all that means is you've done 2 or more isometric, remember, which just means rigid. You're keeping the shape of your figure. So here I have a line segment. My line segment is going to be R is at -8, 5. S is going to be at -6, 8. And our first transformation is going to be, so this will be R prime, S prime. So that's going to go forward 5 and down 2. Well, let's put our RS on here. So we're at -8. Oh, great, I went off the chart. -8, 5. So this is going to be R. And S is going to be at -6, 8. So I'm right off the chart on both sides. There's my image. That's my pre-image. So this is our pre-image. That's what we're starting with. So my first transformation is going to move everyone forward 5. So the x-coordinate here is going to be at a -3 and then down 2. 5 minus 2 is also going to be at 3. So I'm going to be at -3, 3. And my S coordinate, -6 plus 5, that's going to be at a -1. 8 minus 2 is 6. So this will be -3, 3. Here's R prime, and -1, 6. There's S prime. So that's our first transformation. But in this case, we have a second transformation. So we have a composition. So I just do each one individually. Now this one we call R double prime and S double prime to show that it is the second iteration. So we take the R prime, and now I subtract 4, so that's going to be -7, and down another 2, that's going to make that at 1. For S, -1 minus 4, that's going to put me at -5. 6 minus 2 is going to put me at 4. So -7, 1, this will be R double prime. S is at -5, 4. That's S double prime. And there is the result of two compositions. Now, if I want to write that as one transformation, or even better yet, one translation, I put the two together. So what did I really do? I went forward 5 and down 4. So the end result is that I went forward 1 unit, and I went down 2, and I went down another 2. So together, that's a result of going down. Whoops, I wrote that as a 2. It's going to be a fancy 4. So I'm just adding those two coordinates. And again, in vector notation, that would be 1, -4. And that's how you would show it as one transformation. So welcome to a chapter on transformations.